So what we have tonight is a really a big privilege, I would say. Simon Carr, we're going to be colleagues shortly at the University of Cumbria. He is an assistant professor at the University of Cumbria. He fell in love with the Lake District. Apparently, his father came from Windermere, and he'd always thought he should tell his son, or coach his son, to become a lover of the mountains and lakes. He had a geography degree, so it's almost in his blood. And he came up here, they had a timeshare in Ambleside, and he was working down south, and he was very heavily involved in work at the Royal Geographical Society. And he thought, this is like 7 years ago, something like that. He thought, Ambleside is the place I want to be. He knocked on the door of the University of Cumbria. By chance, they happened to have a post going. And bingo, he became the associate professor. And we've had contact with him before because we're privileged, my wife and I are privileged to live in Grisdale Valley. And by chance, I discovered through him that the Grisdale Valley is one of the places where he brings his students every year. And there are 5 particular locations in the valley which apparently are perfect stages in the whole glaciation process. He's a specialist, I was saying, glaciation. Some of you have seen the press release I put out on this. So he is a person of huge knowledge of this area. He's chosen a theme. We didn't force him on this. He came to us, which seems to me absolutely fantastic and appropriate. And I've asked him if he can try and steer it towards the Alswater Valley, but you know, climate change in the Alswater Valley is a rather difficult concept. I think he's made an effort. I've had a privileged look at what he's going to say, and he does a very good job, I would say. So, with those few words, we're very privileged to have you here tonight. Thank you very much indeed, Simon, for coming. And over to you.
Thank you very much. And I think definitely for me, the privilege is mine, actually, because you know I'm an off-comer. I've come into this place recently. I've been only in Cumbria for about 5 years. And part of the reason actually for wanting to give this talk is, you know, as an academic, we want to provoke, we want to challenge, we want to come out with some ideas that throw the audience and go, actually, I disagree with that, or I've got things to offer on that. And just looking around the room, there are a few faces that I recognise, there's a few faces I recognise from other places. You've all got in your heads, in your houses, in the organisations that you're working for, lots of information that is really, really maybe hyper-local to Ullswater, or it may just be in Grisdale, or it may be just in Glenridding. But you've got expertise and experience that goes way beyond what I've got. And one of the reasons for doing this talk is to hopefully try and open up a conversation, because I want to hear from you what the information is that you've got. There's some little bits that I'll be picking out within this talk, and I'll say, actually, can you help me on this? Because this is what I think we want to find out. You might have the data that we need. So, as Tim introduced me, you know, I came here as someone that was obsessed with glaciation. I trained as a glaciologist and a glacial geomorphologist, looking at the landscapes of glaciation. But more recently, my work has become a little bit more skewed towards looking at the climate story, because you can't study glaciers without recognizing how rapidly they're melting and retreating. I used to spend 3 months every year working out in Iceland, in southern Iceland, on a series of glaciers, looking at the landscape that they were generating. You can't go there without going, oh my goodness, how quickly is this landscape changing? So inevitably, if you study glaciers, you start studying climate change. If you start studying climate change, you start studying people. Because actually the story about climate change, and the story that I'll be talking about this evening, actually focuses on how people place themselves within that. Because I'm sure, stand up if you don't have an opinion on climate change. See, we've all got a viewpoint. And what I'm going to hopefully try and do within this talk will be about an hour or so, but I'd encourage you, if you want to stop me, interrupt me, if anybody on Zoom wants to sort of say, hang on a minute, I want to query this, please do so, because for me, a talk like this, it's a two-way process. I want to be hearing what you say as much as what I maybe blether on about. So, with that in mind, our starting point is this. It's quite familiar stuff, I would have thought, to most of us. Little droplet of water. Normally, looks like that on the left. On occasions, it looks like that on the right. But it's worth remembering that those droplets of water are actually what makes this planet unique. Earth is the only planet that has got a massive store of water in both liquid, solid, and gaseous phases. So our whole planet, everything that shapes our planet, is driven by these little droplets of water and what they do. And you think that the amount of water on the planet hasn't changed. But what has changed is how it's cycled around, how it moves around. And we can see how that record of cycling of water takes place by looking at that. Look at that fabulous landscape that you can see there. This is a photo by Dave Massive, professional photographer who comes up here a lot. If you look on his website, they're absolutely stunning photos of Ullswater. He doesn't live around here, but he is absolutely in love with Ullswater.
You can see our house. The two lumps of white there, that's the huntsman. The huntsman's tower is number 1, and we're number 5.
Excellent. I didn't choose it deliberately, promise. But if you look at that landscape, everything about it is driven by water. From the blue of the sky, that's water vapor. From the clouds that are producing the rainfall and precipitation that affects the landscape, to the frost that shatters the rocks that you can see up here on Sunday Crag. Frost shattering that takes place there. Those are the things that are happening in the present day. But of course, this whole landscape, Drysdale and the Ullswater Valley itself, is all shaped by glaciation. So we've got a landscape here which is completely driven by how water moves around. So if we want to read this landscape, what we're really doing is we're trying to read what is water doing around this. What are those droplets doing? Because those droplets of water, depending on how they fall, where they fall, when they fall, what form they're in, completely change the landscape that we sit within and we live within. So if you look at that landscape, and I look at this as a glacial geomorphologist of the past, I don't really study much in the way of glaciers nowadays, unfortunately. It's quite a depressing subject. It's got to the point where I don't want to go back to Iceland and do more work out there, because actually the glaciers that I've worked on, some of them have disappeared. So a lot of the work I'm doing now is about saying, actually, how do we deal with that challenge that climate change is facing us? But you look at that landscape and you can read it. As Tim has said, Drysdale's got this beautiful record of past glaciation. That past glaciation is a record of past climate change. And we can use the landscape, we can read that landscape and say, well, what has happened in this particular landscape over time? Now, the landscape of Cumbria and the landscape of the Lake District is really distinctive in Britain. You only see the landscapes that we see here on the western coast of Britain. If you go just a little bit, I'm sorry, I'm a little bit, need to go that way. If you go eastwards, go over to Crossfell, Great Dunfell, over onto the Pennine Escarpment and onto the Yorkshire Moors. The landscape there is still high elevations, they're still mountains, they look like mountains in the same way. They're all very subdued topography, big plateau areas. Whereas the Lake District is a landscape of deep glacial valleys. So if we want to read this landscape, what we can first of all say is that the majority of time that this landscape has been exposed, it's been affected by mountain glaciers. The sorts of things that we would see maybe in the present day, in Norway, Central Iceland, that's the default state for this landscape. Every couple of 100,000 years, we get another glaciation, we build up mountain glaciers on the western frontiers of Britain. Occasionally, we get a big ice cap. 20,000 years ago, there'd have been about 2 kilometers of ice above your head. But that doesn't happen very often. That's the only time when the Yorkshire Moors get affected by glaciers, is when we get these large ice sheets covering us. So Ullswater, Drysdale, Deepdale, Dovedale, all of the lovely valleys that surround us here, essentially are a reflection of mountain glaciers. And if we look at the long-term climate record, so this is the record of atmospheric gases taken from bubbles trapped in the Vostok ice core, which is in the central summit area of the East Antarctic ice sheet. It's the longest record we have on land of high resolution changes to our atmosphere, because the gas bubbles that are trapped in that snow as it falls each year and then gets compressed and compressed and compressed, gets trapped and stored. So what we're seeing here is a sequence that goes back over 500,000 years, 800,000 years of the climate record. The top line, the red line, is the concentration of atmospheric carbon dioxide. The bottom line is an isotope of hydrogen called deuterium, and that's used as a proxy by climatologists for temperature change. So we can use the Antarctic ice cores to give us an indicator of what climate was doing. So we can see, well, tell me, what can you see in that record? How has climate changed? Is it chaos?
Yeah.
Correlates. So first of all, who said correlate now? So that's a good word to come out. Yeah. First of all, you can see that carbon dioxide and essentially temperature go hand in hand. They follow one another. And if you look carefully at that sequence, you'll see that we go through cycles. The glacial interglacial cycle that signifies the ice ages. The Quaternary period of the last 2.5 million years has, is colloquially known as the ice age, the time of glaciation. So when the curve is down towards the bottom, we get large amounts of ice covering the planet, including the British Isles. But for the majority of that time, glaciation that we get in the British Isles is just in the mountains. It's only at the very, very bottom of these little troughs that we get the large ice sheets that form. People think about the ice ages. So the other thing that we can see from that record is actually how much we think temperature has changed. Global temperatures through the glacial interglacial cycles over the last 800,000 years have ranged, the temperature range of about 9 degrees Celsius. So just keep that in mind. 9 degrees Celsius is enough of a change to go from no ice at all in the mid-latitudes to large ice sheets covering about a quarter of the Earth's surface. So I'm going to start off with a little question. Why isn't the Lake District glaciated now? Why are there no glaciers in the Lake District? There should be. I'll show you why in a moment. Strictly speaking, we should have. Oh, that's the view down from Roughwaite Lodge. I'd like to get another Grisdale shot in before we move on. Or looking up towards Hartsop. If you look in all of the higher valleys of the Lake District, you can see the moraines of the last glaciers that formed in this region about 10,000 years ago in a small, short episode of climate cooling called the Younger Dryas. But strictly speaking, we should have those glaciers here now. It should look, Drysdale should look like that. That's one of the outlets from the Folgefonna ice cap in Western Norway, just south of Bergen. And elsewhere, we should see lots of little glaciers extending out from the plateau areas of the summits. That's what should be here now. I remember a few years ago, Terry Abrams' film on Helvellyn. I talked about that then. Anybody who watched the DVD will have seen the extended bit where I say, well, there should be glaciers here now. The number of emails I've had from people going, no, this is not right. How can you say this? But there should be glaciers here now. So anybody here a member of the Rays Ski Club? Oh, that's disappointing because I've got a question for them later on. But no, really, you should have year-round skiing here. Wouldn't that be lovely? Ice climbing, guaranteed. But we don't have it. But we know from looking at our landscape that landscape reflects a default of glaciers being in this area, scouring out the valleys that we see around us. So why aren't there glaciers? Well, there should be. And if we look at another icicle record, this is just the zooming in of an icicle record from the Greenland ice sheet, from the North Grip icicle record, from the summit of the Greenland ice sheet. Because it's much closer to us, it's a much better regional climate indicator of what we see. You can see here, the red in this case, what we have here is the concentration of methane. So it's another greenhouse gas, not carbon dioxide, it's another greenhouse gas. But again, it typically, over the last 800,000 years, follows climate. And what we see in that curve is we were coming out of the last glaciation, the little dotted red line is the amount of shortwave radiation, solar insolation that we received. So you can see that climate was following the amount of radiation that the planet was getting from the sun. That's driven by the way that the Earth orbits around the sun, how the eccentricity of the orbit, the change in the angle of the orbit, and also how it kind of rotates on its axis, how that changes the amount and the distribution of energy that we get from the sun at high to low latitudes. But we can see that as we come out to the last glaciation, we can see that the methane record broadly follows that climate with this one big blip. This is that Younger Dryas episode that happened 10,000 years ago that was caused by the collapse of the Gulf Stream as a function of the collapse of the large ice sheets around the North Atlantic. So there was a little episode here where that completely changed, but we go into the current interglacial about 10,000 years ago. And after the peak of the interglacial was actually only about 9,000 years ago, the sun's energy that we're receiving at the mid-latitudes is actually dropping away. And you see, up until about 5,000 years ago, our methane record follows that. And then it changes, it goes back upwards again. Now, what I've done on this diagram is I've just drawn on a line, which is an approximate line of where the threshold of that methane concentration, that temperature proxy would need to be for there to be glaciers in Britain. So you can see that below there, this is when we got glaciation in the Lake District last time. And look, we nearly got there. We nearly got there about 6,000 years ago. And if you go to the Cairngorms, you actually see evidence of the tiniest glaciers that we had on the northern side of the Northern Corries up to maybe 1,000 years ago. But then it went the other way. Any ideas why?
Ruminants.
Ruminants, what, releasing lots of gas?
Yeah. Maybe.
Okay, that's a good start. So what else could be releasing lots and lots of methane?
Permafrost.
Okay, could have been melting of permafrost, but we were cooling, so permafrost would normally be accumulated by then. Now, the climatologist, Bill Ruddiman, North American climatologist who's worked a lot on the ice core and the ocean records of long climate change, has looked at this study for about the last 30 years and been sort of thinking, what on earth would happen at this time? What happened now to change that methane record?
Cutting the trees down.
Who's cutting the trees down?
Captain,
Yeah, why were we cutting the trees down?
for livestock.
Agriculture. The first civilizations, large-scale civilizations, developed on river floodplains. Tigris, Euphrates valleys in the Middle East, down into Southeast Asia, the Mekong Delta and Valley regions. In those areas, that's where agriculture started. And what did we do? We drained river lowlands. You drain river lowlands, you get a massive release of methane. So this turn here is essentially what happened when civilization began, or large-scale civilization. So we start seeing around 5,000 years ago, humans are already doing sufficient work in the landscape to change the chemistry of our atmosphere, to change the way that our climate system behaves. So strictly speaking, we should be down here somewhere. We should have glaciers up there right now. But actually we can go back 5,000 years and see, that's why it's not. So that's the long-term record. You've seen that diagram, 9 degrees of temperature change between the glacial and interglacial cycles. This is the present day. We're coming across to the present day here, but this is the Antarctic ice sheet, which is a long way from water sources. It accumulates very, very little snow in the centre. So I had to draw on where actually our atmospheric carbon dioxide is now. So as of today, literally today, atmospheric concentration of carbon dioxide in the atmosphere is about 420 parts per million. Lift the chin up because it's a shock, isn't it? It's terrifying to think that we are now at a situation where our atmospheric chemistry is the situation that is way outside anything that we've ever experienced in the last, well, probably in the last 60 million years. The last time we had atmospheric concentrations as high as that were when the dinosaurs ruled the planet.
Did it go up as steep as it was on Carr?
Yeah, on the timescale that we're looking at there, it's
Yeah.
essentially a vertical line. Now, of course, remember something that you said earlier on, correlation. What's the correlation between carbon dioxide and temperature? Are we in a situation where our climate is going to be changing on a much, much shorter timescale? And this is why climate change is the biggest challenge facing humanity. It's a massive global issue. when we see a diagram like that, you suddenly go, oh my goodness, that puts it into a little bit of perspective. That's not based on supposition, that is observed data sets. Whether we're talking about weather station data in the last 150 years, or whether we're just taking the trapped gas from bubbles that have been sealed in the ice sheet for the last million years. And that's why we have the Intergovernmental Panel on Climate Change. So the big picture that we're talking about here is that we recognise that climate and climate change is something that's one of the biggest challenges that we face. Now, the United Nations in 1990 brought together a group that was called the IPCC. That's a group of scientists, researchers, politicians, economists that look at and review all of the academic literature that's published relating to climate change. They do no research themselves. All they do is compile the data that people like myself collect as part of my job. And every 5 or 6 years, they come out with a report. Starting in 1990, the last one has just come out this last year. So the IPCC is split into 3 working groups. The first one looking at the physical science of climate change. The second one saying, okay, what's the impact of that? You know, what is the vulnerability that we have to climate change? And the third working group comes out with, what can we do about it? And you'll see that COVID impacted the IPCC's work. It delayed its publication by about a year or so. But you can see that over the last 2 or 3 years, they've come out with these reports. If anybody has a problem with getting to sleep at night, please feel free to download one of these. They're all freely downloadable. The 3 reports together are constitute, I think I worked out, it's about 35,000 pages of document. It's terrifying to look at. Luckily, what they do produce is a summary of policymakers, which is about 40 pages long. And that's much more palatable. It's always got pretty pictures in it. And so that came out this March. Every year, every assessment report that comes through, they have 3 working groups publish on their particular areas, and then they say, right, this is how we put it all together. This is what it means. This is the state of our climate. And what this does is this provides us a global view of what the climate system is doing, what is being changed, what is changing, what are the impacts of that, and also what do we need to do to limit the potential damage from climate change. But that's kind of a big nebulous thing, isn't it? It's quite it's an invisible thing to look at. Now, have you seen climate change? You know, can anybody in the room say they've witnessed climate change directly? You might have done. We'll hopefully pick up on some of that in a little bit. But what we're hopefully going to do now is start to try and say, well, how do we take that big picture and scale it down to a landscape that we're familiar with? How are we seeing the impacts of that climate change now? What's going to happen in the future as a consequence of that? But the other element that comes out from primarily the work that's taken place over the last 30 years with the IPCC is the recognition that it's not just our climate system that humans have changed. We're actually fundamentally changing the way that the planet operates. So all of the major sort of biogeochemical cycles, those things that cycle things like carbon, nitrogen, water around the planet, we are actually having a huge impact on those things. And that's reached the point where this year, we've actually had the proposal, it's gone through to the people that determine the geological column. We've now decided that in 1950, we entered a new geological phase of Earth history. We've left the Quaternary, we've left the period of the Ice Ages, we've now entered something called the Anthropocene. The Anthropocene is something which is utterly unique in planetary history. And I'll explain why in a moment. But what the Anthropocene is defined as is the age where humans are just as powerful as all of the natural forces that have shaped the planet for previous 4.6 billion years. So climate change is seen as kind of one of the biggest indicators that we have entered something which is completely new and novel, and also slightly terrifying. Because for the first time in Earth history, it's not the unconscious laws of physics, of chemistry, that are driving and shaping the planet. It's actually conscious thought, volition, ideas. Again, to give you an indication of the degree to which we're able to resculpt our planet, humans now move more sediment around the planet than all of the world's rivers put together. And we've done that for the last 1,000 years. So it's not something that's just recent. That's something that actually, during the medieval period, we were doing enough to move sediment around our planet to compensate and overcome the role that all of our rivers play. So this period that we're now entering, and we thought to have entered it in 1950, and that's the reason that we have 1950 as the onset of the Anthropocene. It's the post-World War II boom. We call it the Great Acceleration. You can look at almost every indicator of social, economic, Earth system metrics, and they all change their angle of sort of progression in 1950. You can go from the number of McDonald's restaurants to the amount of sediment that's being transported to river mouths. It's a whole swathe of things happened in the post-World War II boom. And when we're looking for a marker that tells us this is a new geological record, or this is a new phase in our Earth history, we need a record that has got a global signature. We need it to have been an instantaneous response. Think of the best indicator we've got of a change in Earth history, of course, was the asteroid that wiped out the dinosaurs. There's a layer of iridium that covers the whole planet. So to define the Anthropocene, we had to find a layer that has been produced instantaneously across the whole of the Earth's surface, all at the same time, that will be preserved for hundreds of thousands of years in the future. And what's, we've talked about oil, we've talked about plastic, we've talked about all sorts of different areas. What we've come to actually is the thermonuclear tests of the 1950s, the radioisotopic signature of the Cold War as being that big global signature. So we entered the Anthropocene in 1950. And it's best exemplified by this diagram here, the Keeling curve, which is just, it's a subset of that record of atmospheric carbon dioxide. This is that vertical line that I showed you earlier on, but just stretched out from 1958, when Charles Keeling first started monitoring concentrations of CO2 at the Mauna Loa Observatory in Hawaii. And you can see over the years it's gone up and up and up. We see that as an indicator of the Anthropocene because we can say, well, what we're seeing here is a change in atmospheric chemistry at global level. But the reason that we're seeing that is because of human emissions of carbon dioxide. And so it starts connecting the physical and human part of our planet. And we know, again, this is data from the IPCC report. So this is the working group 3. So this is one that was looking at mitigating the problems with carbon dioxide. We know what the problem is. It's our emissions of CO2, carbon dioxide, methane, CH4, changes in other gases like fluorinated gases, nitrous oxide. These are all byproducts of our operation on the planet's surface. But the largest component, this blue component, 65% roughly of all of our greenhouse gas emissions driving climate change are coming from carbon dioxide burnt from the use of fossil fuels. So for energy production, for transport, and all those sorts of things. If you look at that record, 1990, the year of the first IPCC report, we calculated that we were emitting about 38 gigatons of carbon dioxide equivalent into the atmosphere every year. That's 38 billion tons of carbon dioxide, just to give you a scale of that. In 1990, we didn't think there was a huge problem with climate change. By 2000, the second assessment report, we knew that there was a big problem with climate change. As our emissions have gone up to 42 gigatons per year. By 2010, they've gone up to 53 gigatons per year. And by the current assessment report, the last data that they published in their 2019, we've gone up to 59 gigatons a year. So the challenge is that we know what the problem is, not really doing a great deal about it yet. And if we zoom purely in on those carbon dioxide from burning fossil fuels, if we just look at the record trend of that, here is a slightly longer-term record of those carbon dioxide emissions going back to the 1960s. The only times that we have seen a drop in atmospheric CO2 levels has been as a consequence of a crisis, whether it was the oil crisis in the 70s, whether it was the collapse of the Soviet Union, the end of the Cold War, or the global financial crisis 15 years ago, and the COVID pandemic. There you can just see a little drop, the COVID pandemic a few years ago. Those are the only times, one exception, that our emissions of carbon dioxide have actually reduced. The only time that we reduced carbon dioxide emissions without there being some sort of world crisis was when we signed the Paris Accord in 2015. We managed to get minus 0.2% emissions that year. Now, you've probably heard talked about a lot in the media, this idea of net zero. We've got to hit net zero by 2050. And that's something that's enshrined in law in the UK. We were the world leader in terms of signing up and writing the Climate Change Act in 2008 that actually said that by 2050, we have essentially got to be at net zero. That the emissions that we are generating will be balanced by the amount that we're sequestering through things like plants and carbon capture tools. Now, to reach that, we have to emulate that drop that we saw in the COVID pandemic every year until 2050. So if we want to reach that net zero, we've got a really, really big struggle ahead of us. If we can do that, and if we can replicate that across the planet, we've got a hope of staying our climate sort of change, our temperature change that we're recording on a global sort of average to within maybe 2 degrees of warming, which has often been determined and described as being safe climate change. There's no such thing as safe climate change, but we'll come back to that later. So before we start pulling ourselves down back to Cumbria, one final diagram. Anybody seen this diagram anywhere? Yeah? Seen the Show You Stripes diagram? It's turning up everywhere now. It was created by a meteorologist at Reading University, Ed Hawkins, who has basically been looking at climate records for all of his research career. This is the record of temperature anomalies compared to, whether it's below or above average temperature conditions compared to the means between 1960 to 2000. The blues are when it's below that, the reds are when it's above that. We're going from the start of the 20th century through to, this is 2022, red line there. So 2021 was slightly hotter in England than 2022 was, but that gives us a record of actually how our temperatures are changing and have changed. The overall range of that temperature variation is about 1 to 1.5 degrees Celsius. It's not a huge amount. Probably the room temperature has gone up by about that since you've been in here. Not really detectable. But let's move away from that big picture and think about what we talked about. Carbon dioxide and other greenhouse gases as being a fundamental driver of our global climate change. Let's bring carbon back to Cumbria. Now, climate change is a strange issue because it's global, it's invisible, it's something that's quite tangible. It might affect other generations, the ones that we are in. It's an invisible, what we call a wicked problem. We often think of it as being too big that we can solve. But equally, it's a strange problem because we know what the issue is. The issue at the moment is we're emitting loads of carbon dioxide and other greenhouse gases. Because of their effect of absorbing long-wave radiation being emitted by the planet, we're warming up the atmosphere, what we refer to as radiative forcing of our climate. And our physics, our understanding of that is pretty solid. We know what we're talking about. So we know what the problem is, we know what's causing it, we know what the solution is. We need to decarbonize. We've got the technology to do that. And how many people in here have got an electric car? Just well, yeah, excellent. So there's one of the solutions. Not quite the perfect solution yet, because how do we generate the electricity that goes into that car? So there's still work to be done. But we know that the technology exists. And believe it or not, we can pay for it. During the previous assessment round of the United Nations, the UN IPCC estimated how much it would cost to translate the whole world economy to a zero carbon economy. In 2013, they said the cost was $36 trillion. That's a lot of money. That's about 10 times the UK's total value each year. And they said that we need to spend that $36 trillion between 2013 and 2030. So over about a 17-year period. So that means every year we would have to, the global economy would have had to have spent about half the UK economy to do that translation. That's still a lot of money, isn't it? And of course, you'll hear people say we can't afford to do that. But let's step back 15 years to the banking crisis. 2007, 2008, 2009, governments and taxpayers bailed out global banking companies. Do you know how much we paid to bail out our bankers? We paid $10.7 trillion. But we didn't pay that over 10 years, 20 years, 30 years. We paid that over 2 years. So anybody that tells you that we can't find the money to deal with this issue, maybe there's some rethinking that's required there. Because we can certainly do it to bail out the bankers. Hopefully, I hope there aren't any bankers in the room. If there are, give us our money back. So we come to Woodhouse Colliery. We know that the problem is that we need to get rid of carbon from our economy. So why, oh why, are we doing this? The estimates are that when Woodhouse Colliery runs, it will be responsible for 8.4 million tonnes of carbon dioxide every year. Now, to put that into context, the UK emits at the moment, 2019, the last year of data that we got, the UK emitted about 350 million tonnes of carbon dioxide. So it's about 3 to 4% of that total. But one of the key elements of the UK 2008 Climate Change Act is we set up something called the Climate Change Commission, which is a government body that looks at how we are going to meet our requirements of the Climate Change Act. Now, Lord Deben, who is the chair of the Climate Change Commission, said of this that that emission of carbon dioxide from Woodhouse Colliery, if and when it gets running, is actually greater than the total amount of carbon dioxide that the UK has budgeted for being released by all coal being extracted and burned in the UK. That's more than all of the other mines that are currently closing down and shutting down and have been put into our projections. Why is it going ahead? Politics. What's the politics that's going on here? Jobs for the poor people of Whitehaven that have suffered in this industrial era. The West Cumbrian Coal Company is actually an Australian company, a group of venture capitalists who have worked out a wheeze of making an awful lot of money very quickly by creating jobs which are going to be defunct within the timescale of this coal mine opening. Sweden is Europe's largest steel maker. And all of the coal that's going to come out from Woodhouse is not the sort of coal that you would burn for energy production. Its only use is in coking for steel production in blast furnaces. Now, since Woodhouse has been approved, we've only got one blast furnace left in the UK called Talbot, and Tata Steel is desperate to shut that one down. All of the remaining steel production in Europe, predominantly in Sweden, is moving to green steel. No coal being used. In fact, the steel industry doesn't want any more bloody coking coal. They don't need it. They've got enough already. But what we're seeing within here is as you say, it's the cynical politics that take place of, well, what can we do to exploit, in this case, an extremely vulnerable community that has been left behind? Let's give them some jobs, throw some money at this place without necessarily thinking of what the future means, because those jobs in Woodhouse are only going to be around for 12 or 13 years before they're defunct. And then who's going to employ a miner then? And as Rebecca Willis at Lancaster Environment says, she's got a paper that's currently just in review with the Open Environment Journal. She's looking at how Woodhouse Colliery, how it can be a case example of how greed and large finance companies are trying to circumvent the legislation that we have within our own enshrined laws. So here's a link between Cumbria and climate change that we probably don't want to be very proud of. It's not something that we should be very pleased with. And I'm glad I've got Rob and Harry in the room today, because of course what we should be looking at are other locations. Places like this, Bolton Fell Moss. Zoom in on Google Earth. This is in the far northeast corner of Cumbria, so not quite in the Ullswater catchment, I'm afraid, but it's, if you think about, all of the peaks that we have on the blanket bogs of the high fells, this is just to the northeast of Carlisle. It's a site of about 550 hectares that for 90 years was used as a peat factory, for horticultural peat, the burning of peat, and it's been used in a pretty industrial way. You probably can't really see the image of the milling machine that was used by Sinclair's to actually stretch out and pull this peat out. Now, here's a slightly different story, because I'm sure you've all heard about the role that peatlands play in storing carbon. If we want to solve climate change, if we want to decarbonise, first of all, we've got to stop emitting all that carbon, but we've also got to suck a load of carbon out of the atmosphere. And one of the best ways of doing it is a peatland. Per hectare, peatlands are about 20 times more effective at sequestering and storing carbon than tree planting would be. And of course, bogs like Bolton Fell Moss, they've been accumulating for 10,000 years. They store that carbon away for a long time. When a tree dies after maybe 500 years, a large chunk of that carbon that's embodied within the tree will get re-released to the atmosphere. So if we're looking for a long-term carbon store, places like Bolton Fell Moss are amazing. And so in 2009, Sinclair's stopped their activities at Bolton Fell Moss, and Natural England took over the site and have undergone a large-scale restoration to return this extracted bog into a functioning bog that will start drawing carbon dioxide out of the atmosphere. But there's a problem with Bolton Fell, because Sinclair's was the largest employer in this area, up sort of just north of Brampton. A number of jobs were lost, livelihoods were lost. Generations of people who'd worked at that site were suddenly saying, well, we've got no future here. Our largest employer has been lost. And there was a lot of resentment to that, understandably. Why is Natural England taking over this site and making us lose our jobs? So a few years ago, as part of the COP26 discussions that took place in Glasgow, there was actually research funding that came around for small-scale projects to get people engaged with climate change. Unfortunately, Rob and Harriet and myself and Emma Austin from Natural England were lucky enough to get one of these grants to create a project called The Moss of Many Layers, about trying to reconnect the community to this bog, to get them to recognise what the value of this bog was. So using, well, a fabulous poem that is now on boards all around the bog, but using connections with the community to hear the stories of those people who lived and worked around the bog, those people that felt a sense of loss, those people that could value what was there around them. And this beautiful map that was produced by Helen Cowan as part of the project tries to distill the science, the social science, the arts, the community work, the future of the bog within here. And the Moss of Many Layers project was all about trying to reconnect that community to not feel a sense of loss at the jobs that had gone, but a sense of pride, because that bog, when it's restored, when it's fully functioning, which is not quite there yet, will be on its own sequestering 23,000 tonnes of carbon a year. That's the equivalent of 100,000 tonnes of carbon dioxide a year. That's one bog, 550 hectares. Cumbria has got something like 30 to 35,000 hectares of bog. Some of it, lowland bogs like this in Bolton Fell, much of it on the mountaintops, on the fell tops. If all, unfortunately, 90% of those bogs are not working properly, they've been heavily degraded. But if you can get those working again, think about how much carbon those bogs are storing on our behalf. Largely without us having to do a great deal, just leave them to it. So that could be a story which is a slightly different way of looking at how climate futures could look. And it's not just about carbon. A bog is a fabulous store of water. 90% of a peat bog is water. If you take a bottle of milk, that's essentially the same consistency as a peat bog that's fully working. About 10% solids, 90% liquid. So that means that if that bog is functioning and working, every time it rains, that bog just fills up with water. And when it doesn't rain, that bog very, very slowly releases that water. We'll come back to the importance of that in a few moments. So there's one little story about carbon, that Cumbria actually could be part of a really good solution, not the problem that we're seeing at Woodhouse. But unfortunately, the hard truth of all of this is that we need to start pulling an awful lot of carbon dioxide out of our atmosphere. If we want to limit the impacts of climate change, there's an awful lot that we've got to pull out. And the IPCC, every sequence that they do their work, they will project what they think the pathways are of how we could decarbonise. And you can see here 5 scenarios. These are the current scenarios that have been put together. You can see the little numbers on the right. So you've got 1.9, 2.6, 4.5, 7, and 8.5. Those are the number of watts of additional energy that we're getting as a consequence of the greenhouse gases absorbing long-wave radiation. So if you think, I'm trying to work out a way of explaining this in an accessible way. You must all remember the old filament light bulbs, a 100-watt light bulb. So think of the sun as being the equivalent of a very, very large version of one of those light bulbs, but it's able to project about 230 watts of energy across every metre squared of the Earth's surface. It's what we refer to as one of the solar constants. That's how much radiation we get from the sun. Now, to keep our climate consistent, we have to emit 230 watts for every metre squared of the planet. Otherwise, we just start boiling. That's how we keep our energy in balance on the planet. What these figures mean are actually how much additional energy above that 230 watts is being kept in our atmosphere as a consequence of the greenhouse gases. So it's not much. 1.9 watts, that seems nothing. 8.5 isn't really much, but it's enough to make a huge difference to our climate system. So, unfortunately, our current trajectory is somewhere in between those two. That's where we currently are. Where we need to be, from what the Paris Accord agreed, is something that's going in this direction, ideally that blue line. So you can see there is a lot of work to be done. Now, as a consequence of those scenarios, what the IPCC produced this year for the first time was this diagram. It's a kind of a rehashing of that show your stripes diagram on a global level. What they did is they showed in their synthesis report temperature since the start of the 20th century, how it had changed. And then, what I thought was something initially, I thought, oh, this is brilliant. What they did is they projected those stripes against those 5 scenarios that they predicted. And I thought that's a really good way of visualizing actually what global temperatures will do. But then what they did is this thing, which actually, on hindsight, terrifies me. Because what it does is it shows the climate histories of those people born in 1950, what you experienced and where you are now, and what you're going to maybe see in your future. Someone like myself, born in the 70s, in kind of, hale and hearty state now, what I'm going to look for in the next 30 years or so. And the most terrifying one is a baby that was born in 2020. What is the world they live in? You can see the colours maybe briefly there from the high emission strategy through to the low emission strategy. This is actually a terrifying diagram of this is what you're facing. Those of you with children or grandchildren at school age or at university age, talk to them about climate change, and they often project a very bleak picture of, it's too late. We're seeing something that's really terrifying. And that's a very, very bad narrative to have, because that disempowers people. And the students that I teach at Cumbria and Ambleside, a lot of those students have already lost hope. The absence of hope is despair. Despair doesn't make you do anything that makes you change your behaviours. Now, I'm working on a project at the moment, working with children in Manchester, working with 12-year-old children who are saying, oh, it's no point, not worth it. We should have done this years ago. We should have made these differences 20 years ago. It's too late now. I'm just going to have fun. And, I remember the teacher at the time said to this girl, don't be so daft. It's like, hang on a minute, let him talk a little bit. Let's listen to what he's got to say, because that's actually a surprisingly common perspective. One that I think is really quite dangerous. Now, what do you think of that diagram? When you look at it, you go, yeah, it's a really nice way of showing that image off. But how does it make you feel? It's not a very pretty picture, is it?
I think one of the issues, unfortunately, the extent that you and others are producing this worthwhile stuff, there are others churning out climate change denying stuff on popular websites, things that people have watched.
Something I should have mentioned with the IPCC.
Perhaps you could repeat his question.
Yes, so that question that came in for those of you on Zoom is about, well, we can talk about all of this evidence, but of course we see climate denialists, climate skeptics in the mass media projecting a completely contrary view of what this actually means and what this represents. The thing to remember within this is that the IPCC report, as I said, compiles data from other people's studies. It draws together everything that it can find with, data search saying, tell me about climate change. It's a bit more sophisticated than that, but it's trawling together everything within there. And as part of the challenge of trying to combat and trying to counter what we see in terms of climate denialism and skepticism, there's been a lot of work done to say, well, actually, how many people agree with that consensus view of the IPCC? And in terms of the climate science community that have kind of provided the data within here, the value is 99.97% of the scientific research is stuff that is distilled into those IPCC reports. The tiniest little fraction is the stuff which is contrarian. Yet a lot of our media will often portray what we call balance as bias. They'll say, oh, no, we know, the BBC used to do it an awful lot. The editorial policy of the BBC would be, let's talk to a climate scientist about this, that, and the other, and then let's talk to someone with a contrary view. And it got to the point, and I know David Shupman, the former science editor of the BBC, quite well. And it became an internal joke. It's like, right, let's get a scientist and let's get a crazy person. And then that was being projected into a mass media to millions as, oh, well, there's clearly a 50-50 split in this, when there absolutely isn't. And, I won't pick on anybody in this room, but if you're of the opinion that the climate change that we're experiencing, that we're monitoring, is within natural boundaries, is not driven by human processes, is not something we should be worried about, you need to get out of the room, because that's not the debate anymore. The debate is, what the hell do we do about it? Because it's not going to go away. We can bury our heads in the sand as much as we like. It's not going to leave us. Anthony Giddens, the political scientist who used to be the proctor of LSE, very, very modest man, came out with something called the Giddens paradox. We won't do anything about climate change until it's too late to do anything. And unfortunately, we're kind of heading that way unless we change that narrative. Because what we can do, and there's already shown it with the story at Bolton Fell, so actually there's lots of really good things going on. So let's move on, let's talk about what that climate change means. So there's all the various models that have been used to predict some of the scenarios that we talk about. But really, when we look at the climate records, we talk about now how much warming is there going to be to 2100. At the moment, it could be anywhere between 2 degrees and 4 degrees of mean warming. But that's actually a meaningless number, because those diagrams up here show the spatial variation of temperature. If you look at the UK for temperature change and precipitation change, actually the mean change isn't going to be that much. We're going to see a lot more change in mean temperatures in the high Arctic regions, what we call Arctic amplification, over the large land masses of the planet. It's going to be other areas which are going to suffer a lot more than we will on a global level. But if we focus in on both temperature change and precipitation change and think about what that's going to do to Cumbria, there's a lot of things that we're already recognizing is already happening. So if we're going to get maybe 3 to 7 watts of additional energy stored within our planet, what's that going to do to the water that circulates around our planet? Because that water is the thing that shapes our planet. So that warming in and of itself doesn't sound like much. It's probably about 2 or 3 degrees warmer in here. All these brains are kind of generating lots of heat in this room. I can feel it's a bit warmer than it was at the start of the talk, but it's not uncomfortable, is it? 2 degrees warming, England's average temperature in the year is about 14 degrees. If it shifts up to 16 degrees, that's not a big deal. But what it does do is it creates a much more energetic atmospheric system. So what we start seeing in an energetic system is a much more volatile set of processes. So let's start now pulling this down to Cumbria. Let's get away from all that big picture stuff and just talk about Cumbria. Here's the record from St John's in the Vale. When I first moved up here in 2018, first thing I did was let's see what data there is around here. Let's find out how much climate has changed. We looked at average rainfall conditions over the course of the year. It doesn't show a great deal. Average rain in Cumbria since 1960s doesn't really show any significant variation. But when you start looking at how much of that rain falls in an individual rain event, then the picture starts opening up a bit. So that top diagram just shows every month since 1989 up till 2017. So we've just got Desmond in there, just on the right-hand side. That's the peak rainfall in 24 hours each month. It doesn't tell us how many peaks there were within that month. It just says that was what the peak was. And what you'll see, if you look at that record, is it's very noisy. But the big thing to recognise is the difference between the minimums and the maximums from the early 1990s to the late noughties. What we're seeing in Cumbria is, although we're not getting any more rain falling, we're getting more of that rain falling in very, very intense events. And you can see that if you plot the same data set using a different way of saying, well, how many heavy rainfall days were there where there was, say, more than an inch of rainfall in 24 hours over the same period? And you can see, again, the data is noisy, but the trend is that it's increasing. So if we're not receiving any more rain, but we're receiving it in more heavy rainfall events, that's telling us our climate system here is in a boom and bust. What that's showing us is that essentially there are times when there's a load of water, when we get a flood, interspersed with times where there's almost no water. And I remember when I moved up in 2018, you know, all of my friends down south, I lived in Oxfordshire before I moved up. So, you know, make sure you've got a really good waterproof. Ha 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 ha. I had 9 weeks of no rain when I first moved up. Summer of 2018 was dry, completely dry. And then September 2018, it all fell out of the sky at us.
So what happened in 1999 to 2003? Was there some event that happened in the country that reduced the volatility?
Sorry, which one are you looking at?
Look at the top diagram between, I think it's
Oh,
about
just the
1990.
curve that you see within here.
Yeah.
Yes, it could be, you know, the atmospheric system is a really complex thing. It could be something to do with a process called the North Atlantic Oscillation. I'll talk about that a little bit later on. It could be part of the El Nino cycle. There are all these cycles that move heat around the atmosphere that do things that we never really understood until, well, we're only beginning to understand some of those cycles now. And it's one of the challenges within meteorology is that it's such a chaotic system. It's often very difficult to find those patterns. But yeah, you're right, there's a gap in that middle part where it just seems to drop away. Again, our records aren't good enough. As, you know, as we go back further than you know, we've got some good Met Office data sets going back to the 1960s. Beyond that, it starts getting really very, very patchy. And to try and understand a climate history with only maybe 60 years of data, and then trying to forecast 200 or 300 years is quite a problematic thing to do. So yes, you picked out one of the areas of volatility that come out within there. But the big picture, even when we, you know, if we scale it big, probably what we'll see in this period, because we look in the, you know, there's low period in 2001 of extreme events. But actually in 1999, where we see that graph is quite low, actually there were more events taking place. There were probably more, but relatively intense rainfall. So it becomes a, you know, the devil is in the detail of these graphs when you look through them.
I guess my point was it was not driven by human event like a change in ice cream sales or policy change or something like that.
There's been some fab studies that kind of try to correlate. You know, there's a great one of shark deaths and the ingredients in ice cream in California. That there's a clear correlation between changing recipes, changing the amount of sugar in ice cream and the number of shark deaths. Correlation doesn't necessarily equal causation within that one, but we don't know. Could be, just be careful if you're in California and eating ice cream. But yeah, you know, that's the thing. These records are basically trying to make order out of what is actually a very chaotic and very volatile system. But what we're seeing, if I show you the next slide, which shows us something I need some help with actually, is not only are we seeing a number of much more intense events taking place, also the nature of precipitation is changing. As we warm our atmosphere even slightly, we're going to have less of our precipitation as snow, more of it as rain. Now that's actually quite important, but we've got no data on this. So here's my plea: if you know anybody in the Ray Ski Club, have they got any data on how many snow days there were on Helvellyn? I'm in touch with the Felltop assessors to get some information from that. But even Shap Weather Station, which is one of our longest established weather stations here, doesn't have a record of how many days snow is lying on the ground, which is a really important thing from a landscape perspective, because snow is a really good store of water. If snow falls out of the air, drops onto the land, it doesn't move that far, it just sits there for a while. And as temperatures rise, that snow melts and starts supplying water. It's a really useful short-term store. But unfortunately, we've got no data on that. The only data that we can use to work on is how many days of frost there were in the years over the period from 1960 to 2020. And the record is pretty noisy again. The red line is just a linear regression going through that. So there is a very, very gradual decline in the number of frost days at Shap. But the thing that I think is more evident is actually there's an increase in the variability. You look recently, we've had 2010, we had 105 days of frost in Shap. Of course, that's when we had the beast from the east. So there was an event there. But then the following years, we go down to less than 35 days of frost. You're talking about a system which is boom and bust all the time. Now, to think about what that does to the landscape, think about that snow as a storm, because I'm sure there's a number of you in this room that have got vivid, probably terrifying memories of Storm Desmond and the impact it had in this catchment. Now, one of the things that's not really been considered is actually that in the run-up to Storm Desmond, weather conditions, temperatures were very mild. Temperatures, mean daily temperatures in this part of the world, certainly from the Shap Weather Station, were about 14 degrees Celsius. That's a lot higher than it would normally be in early December. And if you look at all the footage that's emerged from all the BBC helicopters that were flying around, everybody getting their footage, the one thing I noticed about all of the imagery of the Lake District, there's no snow on the fells. So that year, probably Storm Desmond, that massive peak that we get in 2015, was probably enhanced by the fact that all of that precipitation fell as rain. You'd normally expect in December a chunk of that precipitation on the higher bells to be stored as snow. But it wasn't. It didn't have any. There was no storage in the mountains that was available. And so, I'm going to skim over those quickly because probably for some of you these are quite traumatic images of what you remember. The evidence of Cooley Bridge being washed away. It was only 2020, wasn't it, that it was reopened. 5 years of major disruption. Then Glenriddick, of course, and then the fact that Ullswater was 3.5, 4 meters above its normal level. You think Ullswater's a bloody big lake. That's a lot of water that's being stored in that lake system. And probably a large component of that should have been sat up on the high fells, feeding the glaciers that should still be up there. If we look at data, this is from Hannah Joyce, who did a PhD at Durham University in the aftermath of Storm Desmond. She worked in St John's Beck, just over on the Thirlmere catchment. And she looked at the historical record that we have of flooding in St John's Beck. And you can see here, this Storm Desmond, 2015. You can probably see that over the last 90 odd years, actually the magnitude of floods have increased. Now, St John's Beck is a tiny catchment. It's kind of cut off because of the Thirlmere Dam. So actually it's only like a 5-mile long river system. Thirlmere kind of traps all of the water and the sediment in that basin. But within Storm Desmond, Hannah worked on actually saying, well, okay, if there's all this water that's being supplied to the catchment, that water's going to be doing work. And she worked out in the 3 days of the flood peak of Desmond, St John's Vale moved 6,500 tons of sediment around. That was stuff that was washed off the valley sides. And again, if you look around the landscape, you'll see the scars, you see the gullies, you see the debris flows, you see the cones of, the fresh cones of debris. They're all related to what happened in that storm. That's the mobilization of the landscape. That's stripping away the sediment and soil from the fell top. We'll come back to the importance of that in a moment. Then that gets put into the river, and the river is transporting sediment through it. 6,500 tons of sediment is quite a lot. Any of you that have dug, a ton of gravel will know that 6,500 of those wouldn't be fun to move around. So we can see that those events have got significant problems when we get that boom, when we get the boom of those rainstorm events. But the flip side is we also get bust, because in between those intense rainstorms, we're actually finding we're getting far fewer gentle rain days. How many days do you see nowadays where you just kind of get that gentle mizzle that you always that made England and Cumbria quite a distinctive place that's just always down? It's not. It tends to be either or dry. We get relatively few of those now. And of course, what that does is that has a massive impact on our landscape. Those images at the top there are of the blanket bogs, just above the catchment here. This is actually just on the flanks of Lone Pot Hill. So just over towards that's Helton Dale, I think, on the other side. But what we see here is this is the blanket bog as it should be. Water at the surface, a lovely store, a sponge of water. The soil, and the peatland soils particularly, are our most important water store. That's the water that actually, for most of our drinking water, we rely upon. That's why we still get our rivers flowing normally when it's not raining. The base flow that comes and feeds all of our river catchments is coming from that water that's stored in the soil. But actually, if you go up onto the fell tops nowadays, you're more likely to see this. Baked, desiccated, cracked peatlands. Where you can see salts that have come up, you can see the pH of this has gone down, so the acidity of this has increased considerably because we've drawn all the salts out by evaporation to the soil. In this case, this again was a site we've been working at today, doing some work. The pH, the acidity of the soil there is the same as malt vinegar. It's not something that plants will particularly grow in. There's some sites that we're working on, some of the peatlands, where the pH is so low, it's so acidic, you've got to wear gloves to be able to pick up the soil because it actually starts stinging. And that's what's happening when we dry out this land surface, desiccate it, cracks and fractures open. What happens when it rains next? Yeah, look how broken up that is, fragmented and friable that surface is. We can see here, if we're in a cycle of boom and bust, what's going to happen is we'll go very rapidly from that to something that looks like this, and then that lot will get washed away. And so what bust means is that those dried out peaks are very, very vulnerable to being eroded and moved around. It's something, again, one of the first things I talked about when I first arrived here was, again, looking at those data. One of the first jobs I had when I moved to Cumbria was I was asked to sit on the State of the Park report that the Lake District National Park produces, looking at basically, what is it about the national park that keeps it special? And this was a diagram. This is my achievement in the whole of that State of the Park report, because I'd only just arrived, I didn't even know what I was bloody talking about. But this was a data set that we were shown in the meetings by John Gorst of United Utilities, showed us this is the colour of the water going through Watchgate water treatment works. That's the water treatment works that's kind of the major treatment stage before that water gets piped off down to Liverpool and Manchester. And what it shows is a scale, it's called the Hazen scale, which basically just shows what colour that water is. The higher up it goes, the darker it is. Now that diagram goes from 1989 to 2013. Notice it didn't give me the data from around Storm Desmond. What that record is showing is over the years, the colour of the water going through Watchgate is getting darker and darker. What does that mean? It's all that peat, it's all that soil being washed into the watercourse and being transported down. Now, the thing that's actually quite frightening about this is if you look at this, it's how the colour is changing. It's getting darker and darker. That means that actually the rate of erosion, the rate of loss of soil is actually accelerating. If it was constant, it would be a flat line. But actually, the fact that that is a climbing curve shows us the rate of soil loss from the fells is increasing. And we had a very good press officer in the university at the time, a guy called Nigel, who managed to get this onto the news stories and all this sort of thing. That, you know, basically I'd estimated from looking at those records that we had about 50 years of soil left on the summits of our fells. Those shallow peaks are eroding at such rapid rates that you can see the hagged surfaces and they start getting undercut and eroded very, very rapidly. That's the picture of what's happening. Now, United Utilities won't release that data publicly. That's the best we could get, is that's a photograph of the report that he had. He said, you can use that, but you can't have the actual data. Still won't let me have it.
That was the sewage they put into the truck.
Well, there's all sorts of it. The reason for it is actually, for them, it was very commercially sensitive, because to treat that water means that the United Utilities costs have gone up dramatically at Watchgate. So, because of course, before that can be used for drinking water, they've got to get rid of all of that darkness. And you know, they were saying, look, the issue is here. If you saw the whole record, you'd realise how big the problem is, which is why United Utilities is very active at the moment, working at catchment level, trying to reduce soil erosion, because they want their cost to come down. And, you know, at the time, you know, a lot of the discussion was like about climate change, but it's also about all those bloody upland farmers with all their sheep on there, eating all of the soil, stopping vegetation growing, keeping this grassy vegetation and perhaps making it more vulnerable to soil erosion. It's a much, much more complex story than that. But there is that issue. You know, people like George Monbiot talk about the Lake District being a sheep-wrecked landscape. You know, the climatic tree line here is about 850 metres. If you go up to Keskerdale or you go up to kind of Mungrisdale, you can find elements of the remnants of the Atlantic oak forest up at about 550, 600 metres above sea level. That should be where the forest should be going up to. So most of our fells should be forested. And one of the issues of it not being forested means you're getting much, much more erosion. Let's just step back briefly to look at the long-term picture of this, because we've been looking at the last sort of 30 to 40 to 50 years. If we look at lake records from Bassenthwaite, or we can get similar records from Ullswater, they've not been published recently in the level of detail that Rich Chibnall has done here from Bassenthwaite, we can start placing how often those boom and busts have happened over a longer time period. And what you can see here on the left-hand side is the reconstruction of the magnitude of floods, how big these floods were, going right the way back to the 1500s, the early 1500s, the late 1400s. And you can see here that essentially the last 40 years or so have been the most dynamic in terms of flood events within Cumbria. We've never seen it quite like this. So how do we solve it? How do we stop those floods? How do we manage the soil erosion that we've talked about on the peatlands and the soils? How do we keep those soils there? How do we let them accumulate? What do we do? If you look further up this valley, you'll see one of the solutions. Anybody here from the National Trust? Goldrell Beck?
Yeah, I wasn't heavily involved in that. I won't take any credit for it.
So, one of the best ways that we can make our landscapes more resilient to those intense rainfall events is by looking at our river catchments, looking at how water is moving through them. Every single river in the British Isles is very, very heavily managed and engineered. Next time you go out for a walk, look at the riverbanks. To what extent can you see walls in them that are basically fixing the boundaries? To what extent, as Goldrell Beck had in the past, has the river just been straightened to get the water out of here as quickly as possible? Let's drain it to remove as much water as we can. How many times have you seen beautiful bare landscapes where the water can just run straight off? There's very little soil there to store that water. So we know what the issues are. We know how to solve it. Let's just re-wiggle the river. Let's make that river bend and meander the way that it always used to. If you think a straight line, a river with a fixed channel size, a straight line can hold a certain amount of water. If you make that river bend, even if the channel profile doesn't change, it's holding far more water than it would have done as a straight line. So let it wiggle. Break down the channel margins, let it occupy a larger area when there's more water flowing within it. Normally, when you, the rule of thumb in terms of hydrology, in terms of how a river should behave, is if you add loads more water to the system, 60% of that additional water should make the river channel wider. 20% of it, 25% of it should make the river channel deeper. And only a little bit allows the channel to go faster. If you think about a channelized system where we've got walls that are fixing it, I live in Kendal, where we've got walls right the way through the town centre there. You can't widen that channel. You can only deepen it so far. So what's going to happen? It gets a lot faster. When it gets faster, it can move a lot more sediment around. Then that causes all sorts of problems within that catchment. So the solution is just to do this. The National Trust, United Utilities, Forestry Commission, there's a lot of organisations up here that are doing some really, really great work, thinking about how do we keep more of the water that falls up on the high fells. So let's restore those peatlands. Let's plant some woodland. Let's get some more woodland on the flanks. All of those things will hold water. If we re-wiggle our rivers, we slow the water flow down. We hold the water up in the headwaters. It means we don't end up with that pulse shooting down right the way through our catchment. It causes all the damage that we saw 8 years ago. So think about, I hate to say it, when the next Storm Desmond comes. Storm Desmond was a 1 in 1,300 year storm, apparently. The forecast now is it's a 1 in 250 year event. And the odds are shortening every year that people look at that. So we're likely to see storms of that magnitude within our lifetimes, really. Think about how this river will respond to that storm. It will be able to hold a lot more water. There's some really lovely evidence from the western side of the lakes, from the Wild Ennerdale project, the rewilding project that started 25 years ago. When Storm Desmond happened, yeah, okay, the river lies there. Yeah, it had a lot more water flowing through it. But it was able to migrate the channel. It was able to move sediment around within the channel. And actually, if you looked at the water itself, when it got down to the lowlands, the water was clear, it wasn't carrying sediment. You look at the River Greta during Storm Desmond, oh my goodness, it was like milk. It was carrying so much sediment around. So there are lots of things we can do at catchment level that enable this landscape to be a lot more resilient. So finally, let's get our water down to the sea. Our water droplet's had its journey. We've got a lot more of its friends falling together in short events. It's running through our landscape. It's doing all sorts of crazy things. Eventually, it will get down to the sea. And of course, sea level change is the big global picture that we all know that's going to be one of the big factors of climate change. And we can see our observations show that sea level has risen by around 15 centimetres in the 20th to 21st century. And it's forecast to maybe go anywhere from between half a metre to a metre over the next 80 years or so. Now, the worrying thing with all of the predictions, these are the current predictions of sea level rise, and you can see here, the IPCC only put in kind of the low risk models here. The dashed lines are actually those that are on the business as usual plan. And the little tiny dashed line is what happens when you get collapse of the West Antarctic and Greenland ice sheets, which is a possibility now. So having gone from saying, well, we might get half a metre to maybe a metre, actually some of the projections now are saying, well, we could be looking at 2.5 to 3 metres of sea level rise. What's worrying within that context of those predictions is this little diagram here. It's not in the current IPCC report. They didn't put it in this one. This shows the observational record from tide gauges up until the mid-1990s and then satellite observation since. And the area that's shaded were the sea level projections of the IPCC over the course of 1990 to 2012. Constantly, our observations show that sea level rise is taking place at the maximum end of their projections. So although we're hopeful that we could get down to half a metre to a metre of sea level rise, actually, this is probably the trajectory that at the moment we're most closely connected to. Now, we're quite a long way from the sea here. The Emont's got to go quite a long way before it gets down to the Solway. But if we look at recent modelling, this was actually done by insurance companies, because of course, if you want to get really good quality work done, you've got to have the insurance companies involved because there's a lot of money in it for them. This is modelling that was done by I think it was Aviva, earlier this year, of the area of Cumbria that will disappear by 2100. The area, particularly around Solway, but also down in northern Morecambe Bay and Furness Peninsulas, those are the areas that will be lost. But the irony is actually, those areas that are being projected to be lost are areas that should be our best defended ones, because those are all areas which are currently salt marshes, coastal salt marshes. Now, historically, coastal salt marshes were seen as wasteland, low value for anything, periodically flooded, always waterlogged, pretty horrible surface to work on. But of course, after World War I, World War II, our need for food was such that we drained them, turned them into agricultural land. Not very good agricultural land. There's a load of salt in the soil. It's not really good for growing much, but it's not bad for pasture. But in recent years, we've recognised that actually those salt marshes do a really important job. Because a salt marsh is formed as the tide brings in sediment, flushes it onto that marsh, and the tide goes out, takes some of that sediment away, but it doesn't take all of it. What that means is if a salt marsh is able to work on its own, it will accrete sediment and keep pace with sea level. So as sea level rises, so should our salt marshes. Great, that's wonderful. In the last 30 years, we've recognised that and gone, well, stop draining these things. Let's breach the sea defences, let them reflood, let them reoccupy, because these are free sea defences. And certainly in the area that I live in South Cumbria, there's a lot of quite valuable land that's just inland from where those salt marshes are. Some really useful bits to protect there. But unfortunately, I've got to sneak over the Cumbrian border into a place called Woods, just in North Lancashire. Again, just on the northern side of Morecambe Bay. Warton Salt Marsh is the fastest eroding piece of coastline in the UK. It's eroded 250 metres in 20 years. Now, 50 metres of that was in 3 days. Guess what caused that one? Desmond, yay! And then more recently, this was just before 2020, just before the lockdown, there was Storm Kira and Storm Dennis, two quite small storms, but they came in quick succession within about 3 days of each other. There was about another 13 metres of coastal retreat just in 3 days from that. This salt marsh is rapidly retreating. It's not doing the job that we'd hope it would do, because what's happening, of course, is we're getting more extreme storm events. We get lots of storm surges, we get lots of waves coming, and we start getting erosion of our coastline. So although our salt marsh might be retreating, we're losing it laterally. So the question is, well, why? Well, let's skip on from that. Why is that happening? Because some work that I've been doing in recent years has been looking at why do some salt marshes, like Warton, disappear at a rapid rate of knots, whereas other salt marshes, taken Tillingham in the Thames estuary, got a very, very similar wave regime. It's an open coast environment like Warton. It should be pretty much the same. That's not changed in 25 years. It's not had any retreat whatsoever. It's accumulating sediment. It's behaving properly. So we've done a project called Resist, where we took cores from those two sites, took big cores of sediment out, we scanned them using an X-ray CT machine to look at the three-dimensional structure inside them, and then we took them to Germany, to this place. This is the Großenwellen Canal, the big flume system, one of the largest flumes in the world. It can simulate waves in coastal storms. The technicians that work with it, it's about 950 meters long. And you can see here, there's the research teams in the canal, actually on the beams that are underwater there. You can simulate wave systems of quite large storms. And what we've been doing is saying, well, what is it about properties of one salt marsh at Tillingham which make it really resilient to wave erosion, whereas Warton is really vulnerable to it? And what we found out is it's our friend the sheep again. This is Warton Salt Marsh grazed by sheep. What those sheep do is they strip a lot of the vegetation. What's left is what we call Buxtonellia grass. And, oh gosh, I've forgotten the other name of the other one that's in there. There's another species anyway within there. But they just create lots of small fibrous roots that penetrate down into the salt marsh sediment. And they create lots of pores and holes that allow water to pump in when we get a storm wave. But because the fibres are all quite small and delicate, they don't hold the sediment together. What we don't have are things like marron grass, spartina. We don't get atroplex, these big, long, thorny species that we see in other salt marshes, which create these big, large root systems that these smaller ones can kind of create a mesh in between. And what we found then is that simply that we've got one salt marsh that's rapidly eroding simply because it's grazed, which has stripped out the variety, the species diversity in the area. And then the other one has been left to it, and it's been really, really well preserved. So let's pull this to a conclusion. So I've kept you going for long enough here. I'm keeping you up far longer than you need to. Hopefully what you've seen is that climate change is an issue we can't escape from. We can't hide from it. We can't ignore it. It's a responsibility for all of us to understand what's going on and also to think about actually the challenges it poses as individuals. Because hopefully what I've shown you within these slides is we can take that global picture, which is a pretty bleak picture, and we can scale it down to the landscape that we're attached to, that we've got this emotional attachment to. We all live here because we love it here. And there's something that you, as a consequence of that, you want to preserve it. You want to keep that place going. You want to be able to hand it down to future generations. And actually, the changes that are needed are quite subtle changes. The changes that are complicated, it's about land management, land ownership. It's about how much money you can get from that land to keep you going. But it's also about how we think about how the landscape should be used and utilised. And hopefully what you've seen in each of these steps has been, oh my God, it's a bleak picture. Actually, there's something we can do. And only a small thing. Let's reduce the amount of grazing sheep on water. Don't need to get rid of all of them. They're actually quite handy ecosystem engineers. They disrupt and they encourage new habitats to evolve. But we can't have the large number that we've currently got, which means we've got to make it easier for the farmers that need that land to be able to earn an income, to be able to maintain that land, to have stewardship of that land, rather than thinking of the land as something that they just simply are taking from to make an income. It's about how do we care for that to be able to maintain that for the future. So with that one, hopefully that's kept you interested. Thank you very much. I hope you found it interesting. And yeah, please drill me with questions. Hopefully I've challenged you with a few things there tonight.
Simon, you kept us going for an hour and a half.
Oh, I'm sorry.
But I've been wondering each time, what it's trying to be and what. You kept them riveted. I don't know whether the Zoomers are still online, but I've been looking at the audience, audience reactions sort of thing. Like those emails. You kept them absolutely on the ball.
Can I go on?
All the time. No, I just think that's a fantastic achievement because you've summarised such a very complex and difficult subject into something in sort of digestible chunks, which I think everyone in the hall here, and I'm sure the Zoomers as well, will feel, learned a lot about. It's all been beautifully summarised in a very clear way. Very rare to get scientists speaking as well. And to fire people up. I mean, I don't know whether we're more pessimistic at the end of this talk.
Yeah, how do you feel? Happier or worse about the whole thing?
Whilst you were talking, I was remembering, I was at COP21 in Paris in 2015.
Oh, wow.
I was talking about various subjects, and Al Gore had a special presentation he was going to do in the plenary session. And his presentation happened the day after the Storm Desmond stories here, and the pictures from Glenmilly. This is where Cumbria hit the world. So he managed to get on his presentation the actual photos from Pooley Bridge and from under the road being twisted in Glenmilly. He inserted them into his talk the day after that event. And so Cumbria hit the international event. Was for me coming from Cumbria. And I remember my wife there was all sorts of problems about has our house survived the storm doesn't. There we were at COP21 in Paris, and it had reached the world stage. And I was wondering how you managed to focus on Cumbria. I mean, such a complicated issue in Cumbria, and I think you've done a fantastic job.
And what's really interesting from COP21 is that agreement, the Paris Accord, is the first time all of humanity has agreed on something.
Yeah.
Now that was a massive achievement. There, I think Glenn Ridding was able to
Glenn Ridding made it on the world stage. Thanks for Al Gore. Questions from the audience? Rob, please.
Yeah, you've shown us a lot of graphs tonight, Simon, lots of up and downs and booms and busts.
Yeah.
Given that the science is so clamorous now, and the peaks, if you like, all the information are at the right hand, high up scale, how are we still doing what we're doing? How is it that the people in charge of making decisions are either sticking their head in the sand or willfully keeping that trajectory going?
That's the $1 million question. Yeah, it is.
Such as change from COP21 to COP26. There are more delegates to COP26 that are sponsored by the fossil fuel industry than from anywhere else in the whole world combined. That's the difference.
You're absolutely right. The vested interest, particularly of the fossil fuel industries, is, think of it as something that's probably 5 or 10 times bigger than the influence that the tobacco industry has played in terms of restricting health knowledge of the damage of smoking. But the other thing is, and we often forget this, I think, with our politicians, is that it's so easy to blame our politicians. You're not doing enough to push this. I remember having, my local MP before I moved up here was Ed Vasey down in Wantage. Lazy Vasey was called. I remember giving him a really hard time about what the hell are you doing? And he called me in for a meeting. He said, well, let me put it this way. I've got a 5-year fixed term job. What can I do about climate change between now and the next election? What can I show my constituents? And I started talking about uncertainty, and he said, no, I can't deal with that. You need to give me some concrete things that I can do and say that will make a difference. And so I think a large problem for Western style democracies is we have a very, very short-term political view. You think about what's happening in America at the moment, the fear of what's going to happen if Trump gets re-elected. That's going to turn everything back 20, 30 years ago. And I always remember, it's Will Steffen, who's a well-known sort of Earth system scientist, saying, what we actually need is a good, benign dictator.
But what we have got, we've got youth, and that's something which is really, having followed the COP processes now, there's fantastic energy in the youth. And I think because they're the first people to be touched by this, hopefully their political movements and actions that young people are going to take to save us. We have to do our bit as our generation to try to provide them everything they need to steer a future which is.
And yet we've got a government which is busy eliminating their power to protest. Just pass legislation makes it criminal to protest. That's what our government is doing.
And
I don't think we should get into a sort of government bashing session, but what you're talking about.
But also a lot of it comes back to the siloing of our education system. Climate change is taught in lots and lots of different subjects at school. It's never connected. You learn it in biology, you learn it in physics, you learn it in geography, you learn it in English. But nobody stops and goes, well, actually, how do we bring those together? As coming from a physical science background, the last few years, all of my research has turned around saying, actually, what you've got to do is work with people first. You need to get people on board with whatever the message will be, whether it's a local message or a global message. And that will be the driver of the change that's needed, rather than kind of this rigid top-down approach. That doesn't work. It hasn't worked for 80 years now.
Any questions from the Zoomers?
No question. There have been no questions. First of all, we must apologise to the Zoomers because we did have some technical troubles right at the start. We got those resolved, so apologies to the Zoomers from that. But they're all lots of thank you very much. Excellent talk.
Thanks, Mum.
But I do have a question. First of all, where is Watchgate?
So Watchgate is the water treatment works that's just off the Shack Road coming out of Kendal. So you've got one of Britain's largest pipelines that goes from there right the way down to Manchester. And that's all the water from the Haweswater catchment that all feeds down.
That's fine. That's all I needed to know. The other question is the droughting and the effect on the peat.
Yeah.
Obviously we want to try and restore the peat bogs, but how do you mitigate the droughting effect. What can you do to reduce that?
So it's something we're
Because
actually
we can't control the climate in this room, but there are things we can do on the peat bogs to.
Yeah,
to reduce the effect.
one of the big things that we're working on at the moment, I'm doing a number of projects with a company that does peatland restoration, so it's one of the large contractors for that. And what we're looking at doing is saying, bare peat is a really hostile surface. It's black, so it absorbs lots of radiation coming into it, heats up really quickly. If you ever sort of feel how effective it is, take your shoes off when you see some bare peat in the sun, walk over it, it's hot. 40, 50 degrees Celsius it can get up to. So anything you can do to insulate that will work. So we're working on it. There's Barker and Bland have got this thing called living carpet, which is a bracken, moss tips, growing tips of moss. And if you could put a thick brash over that surface, that will insulate that surface and keep it protected. If you put stuff like sheet wool into that mix, sheet wool is an amazing material to bind that stuff together. It's also thermally very efficient as an insulator, so it stops that heat percolating down into the soil. It's also really good at holding water. So at the moment, we're doing a lot of experimental work saying, actually, talking about sheep as being part of the problem, they could actually be part of the solution. The challenge is when you get bare peat, that's almost impossible to recover.
We did, that was on King Plateau about 20 years ago when Mum used to live there.
Yeah.
They stopped the sheep grazing for a couple of years right on top of the plateau, which is a really good carbon store up there. They put heather brush on, they put metal sort of containers around the roofs that have been eroded so the water didn't drain away anywhere. And after about 5 years, it all grew back and the top is now not black, it's green again.
That's it. And
Can you just repeat, sorry, for our Zoomers, we just need to.
so that question is what we were saying there about the how to restore those bare peats when they're if you exclude the sheep, if you allow a heather brash or a bracken brash that you put over that surface to protect it, it does work. It starts recovering that peat bog. One of the questions we have, the ongoing ones, is that most research projects are 3 to 5 years. And so we don't know how long it takes over a longer period of time. So some of the commitment we've got to Bolton Fell Moss is actually working with Natural England for the next few decades to actually try and track how is that restoration working. So we're every month at the moment, we're going out doing greenhouse gas flux measurements, basically see how much carbon is being lost or how much is being stored by that bog as it's recovering. But we need to do that over decades, unfortunately.
Maybe one last question, yes. Yeah. No, I mean, yeah.
One of the real problems is greenwash, where this is not entirely direct with the government, but a lot of legislation and suggestion has come across. So if we all do a little bit, it will make a difference. So it has been embodied. So I think about pension funds, for example, the task force on climate makes financial disclosure. But as you pointed out recently, firms can make the disclosure about what they've done, but actually doesn't make any difference to the global climate or anything like that. It's a bit to show they're doing a really bad job at adjusting to climate change. So yes, it sounds really good, and we've got this in our accounts, our annual statement. So we're doing our bit to tackle. And I think this is almost as much an enemy as the climate change deniers, because it gives a false impression to many people who are only slightly interested in climate change, not a lot, that actually things are being done. But you have to go to a pretty specialist event, opposed to an ordinary person, to discover how superficial all of this stuff is.
So just to paraphrase for the Zoomers, what you're sort of asking about there is the role that things like people doing carbon offsets and carbon credits, if that's actually making any difference to the issue, or is it just a greenwashing thing? And it's a really challenging area. I think the whole use of carbon is a resource, and we have to think about it's got a value. Trapping it in the landscape has a monetary value in some shape or form, which means inevitably someone's going to try and make money from that. Someone is going to try and monetize that. And we're seeing that at the moment. It's like the Wild West, that you get all these firms. I've been approached by a number of them saying, can you validate our carbon accounting of this, our estate, or whatever, so we can get cash the carbon credits for that. And inevitably I go, no, thank you. That's not going to work. You're looking for me to make a lot of money. We're actually, planting all those trees. It's actually going to release more carbon in the short term. It's maybe 20, 25 years down the line. It will give a benefit. But I think it is part of the solution, because I think that if we can build robust checks and measures to actually be much clearer, much more robust about, first of all, how much carbon there is. Now, we don't know how much carbon is held within all of these peatlands. We can go, well, we think it's about this much from an estimate of the area, but we don't know how deep that peat is. We also don't know how quickly it's accumulating or being lost. But if we can build those frameworks, then I think that does open up the opportunity to work with the private sector.
Yeah.
Where
there is action afterwards.
yeah, and just this afternoon, I was actually talking about a project where we're trying to work on a mechanism to move forwards from what the peatland code is, which is the current way of taxing and working out the credits for peatland restoration, which is a very, very crude tool. And, you know, it's acknowledged to be a crude tool. How can we improve that? Start thinking about not just the carbon, but the water it's storing. So the flood attenuation it's doing, water security it's providing. If you can start building those in, I think then that's where the private sector can have a big part to play, and that where that offsetting will be useful.
Yeah, thank you.
One of the questions I said I was going to ask you was, well, hopefully we'll have some donations both from the hall here and from the Zoomers. Which charity would you be interested in?
Well, I think
making a contribution
to be perfectly honest, I think it needs to go to this catchment's charity, to the charity of the Friends of Wales Waterway.
Oh wow!
I mean,
it's Before I just hand over to Gordon to close the meeting, just like to tell you that so we're having a break in September. We're coming back on the 5th of October, and it's going to take place in Bullybridge at Parkin Hall, and it's going to be an amazing talk. In fact, one of I see in the far back of this room, one of the speakers is going to be Daniel Holder here. We're going to have a talk, and it's going to be called "The Challenge of Managing Sustainable Tourism in the Ullswater Valley," and it has a stellar panel. We have Jim Walker, the president of the Cumbria Tourism. We have Rachel Bell, head of marketing business development for the Ullswater Steamers and Lake District Estates. And we have Daniel Holder, the CEO of Quiet Sight. So we're going to have 3 people on a topic, I think, which is of interest to all of us and fits very nicely into this series that we've been having over the last few months. I'm also going to distribute in the coming days a questionnaire for people who've been attending these talks to see whether we've found the right balance of subjects, the right themes, we got the right time, you know, what sort of rating, if we can have such a rating. Are people getting a good deal? Are there things which are missing? The audience we have both on Zoom and locally are addressing correctly. So I'll send out the questionnaire. It'll only be it won't be a couple of pages, it'll be a couple of questions, that's all, and I hope you'll be able to fill them in. Without further ado, then I'll pass the floor to Gordon, who will give us sort of vote of thanks.
Right, yes, I'd like to thank Simon. I mean, right. We're not really here to do politics. We all know, we're all well educated, we all know what's coming in terms of climate change. You all know what you have to do in terms of doing your bit to make it less. This is more about starting a discussion about what we can do what Cumbria can do, what Ullswater can do to mitigate those effects. I came here thinking, right, what do I invest in? Do I invest in vineyards? Yeah, or rice paddies? I was hoping to see what the future might be. I certainly won't be investing in ski chalets looking at that. But this is the effect that it's going to have on us in terms of our day-to-day livelihood. We do agriculture, we do tourism. I'd like to challenge Simon too to get more seasonal data, because the farmers need to know. I mean, we know we can handle farmers know they can handle most of the key events. If Devon comes, it comes and it goes. But they're as interested in terms of, you know, are we going to have perpetually wet Julys and wet Augusts, and how do we deal with that kind of thing? You know, is there going to be a long drought in May and June, which is, from my own observations, that's what I'm seeing. Is that becoming the norm? So can we have the seasonal data and those seasonal trends in terms on a month-by-month basis, because we can start to use that. And lastly, if there's initiatives that you're doing that you would like people in the audience to help with people on Zoom in terms of measuring or getting out and doing some of the mitigation work that we know is going to need doing, then do let us know so we can pass it on. We have access to a huge pool of very enthusiastic volunteers, and do please let us know. But I'd just like to thank you again, Simon, for an excellent talk. And we look forward to you coming back in a year or two's time to give us an update. Thank you very much.